So I expect you guys to know the basic graphs of several functions. The first two that we're going to talk about are just sine and cosine. Then tangent would be another kind. Cotangent, secant, and cosecant. So cosecant, cotangent, and secant are not really that difficult once you know the first three. So let's start with domain. Back in algebra, when your teacher asked you for domain, what did your teacher want? All the x values, yes. Woo, that's not a pen.
Hey, you too.
Now, technically, domain is all the x values for which the function is defined, but if you just wrote the x values, I know what you mean. So what is the range?
All y values.
All the y values for which the function is defined, but we'll just say all the y values. Amplitude.
Maximum y value.
Yes, max, and in our case, because it's cyclical, it also goes down to a min. So the definition that your book uses is distance from center line to the max or min. So distance from center line to the max or the min. There's a formula your book uses for amplitude, but in my opinion, it's kind of one of those obvious things once you see the graph what the amplitude is. And the period is the distance over the domain for which the graph to complete one cycle. So because of what our graphs are asking us to do, usually in science, the x-axis is your time axis. But we're just going to say it's the distance over the domain for the graph to complete one cycle. I am not going to give you like a vocabulary test by any means, but pretty much on every question from now until the end of this class, any of these questions are legit. So I could say, what is the domain of this graph? What is the range? What is the amplitude? Some of those are easier to answer than others. So let's start with our sine graph. I want you to grab your calculator.
The batteries are low.
That's okay.
Change the batteries. Just so you know.
How do you have batteries?
What? Yeah, it's called a wabbit. Right. Okay, so please type in sine of x.
You know you can use the number pad on that? I don't know that.
We can have this in radian or degree mode. Do you guys have a preference?
My calculator died.
I'm already in radian, so go in radian.
Oh, you have to use radian mode?
It doesn't matter, but for what we're about to do.
Mine doesn't do it.
I don't have batteries with me right now. Okay. Now, if you just hit graph, you have a standard negative 10 to 10 window. No, you're probably not going to see much at all. At least nothing very exciting. So what I want you to do is I want you to go to zoom. And I want you to choose one that looks like it looks appropriate for our class.
Standard.
How about Trig?
Oh. I was joking. I can't joke with this.
Okay, there you go. Can everyone please get that on their screen?
1. No.
I got it.
5 over 2.
Okay. Now, if you hit the trace button and you kind of scroll to the right, can you try to get your trace button bug to get as close as possible to where mine is? Yes.
My calculator has a dark and light.
Oops, that's
It has what?
cosine.
It's like dark and light.
The axis is dark?
It's all dark.
Yes. You never got the graph? You typed in sine? Your plots are on, kiddo. So go to y equals and turn your plots off. Does anyone think they know what x value this is that's roughly 1.5707963? It's half pi over 2. What do you notice is the y value? 1. When you're at pi over 2 on the unit circle, what is your sine value? 1. So coincidence? I think not. All right, let's give ourselves a little bit of a sketch, and you guys are just going to have to trust me for a minute that this is what it looks like. I'm going to have you mark what are called quarter points. So if the period of a normal sine graph is 2 pi, think about a unit circle. It would take how much of a rotation to get all the way around a circle? In radians. 2 pi. So does that make sense that a normal period of a sine graph would be 2 pi then? So right here is 0, and out here let's call it 2 pi. What I mean by quarter points is I'm literally going to mark it off into quarters. So what would be smack dab in the middle? How about pi? And then what's in the middle of those two? Pi over 2. And then does anyone think they know what's here? 3 pi's over 2. This is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Reduced fractions, of course. Okay, the other thing I'm going to want you to mark would be, they're kind of like asymptotes, I guess, but I just mark my amplitude. What was the highest? Woo, pretend that's a line. And the lowest, what do you think that is? So mark that as -1, and this guy is +1. And does anyone remember, and maybe it's still on your calculator, where did my sine graph start? Does it start at 0 or does it start at 1? It starts at 0. Okay. When you have quarter points marked, you can mark in a pattern. And I always tell my kids to mark, I mean, this will seem babyish to some of you eventually, but sometimes I have you write it off to the side, middle, and then it'll go upper. And then where do you think it goes next? Middle, lower, middle. See what happened there? No. It all relates back to the unit circle, so if you ever got stumped, you could either use your calculator or the unit circle, but eventually, and that's going to happen very soon, you guys are just going to memorize what sine looks like. So now do the best job you can. Woo, that's really ugly. Okay. And try to connect that curve. Do you suppose that this is where the graph ends forever? No. What do you suppose happens? It keeps going forever and ever and ever, yes. We're usually just do one period. Well, for the first two functions, yes. For domain, what would you call the domain if this did continue forever and ever?
Negative infinity to positive infinity.
Yeah, you can either say all reals, or I like what Hannah told me, negative infinity to positive infinity.
What is all real?
All real numbers.
You want us to always do
Okay, range.
-1, 1.
Range is -1 to 1. Very good. Your book, and depending on who you had for Algebra 2, you might be used to this for your notation. Inequalities. I prefer bracket interval notation, but it's up to you.
Oh, I remember.
-1. Yeah. I like the brackets better, but it's to each his own. Okay, amplitude. The amplitude is from the center line up or the center line down. So amplitude, you just tell me how far.
1.
1 unit. And the period, how long did it take for it to complete one cycle?
2 pi.
2 pi. Very good. Okay. Whoops. I'll go back.
Did you know? Sure.
Okay, our next function is cosine. So please go to y equals, change your function to say cosine of x.
Oh, wait, my calculator's dead.
And your window's probably still fine. You can change it if you want. Oh my goodness, I wish I could draw a straight line. It just seems wrong, doesn't it? It's because it starts like in the middle. I hate it. I think of a something about a cow. I don't really know why it reminds me of a cow, but it does.
What?
Yeah. Okay. So on your calculator, where do you notice cosine begins at 0? Is it at 0, the origin, or is it up? It's up at 1. Guess what? Those quarter points you guys came up with are going to be the same quarter points. So this is 0, this is 2 pi. And if I marked off the quarters, this would be 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and 4 pi over 2, which is 2 pi. What I'm doing is I'm taking the length of the period and I'm dividing it by 4, and that tells me, that would be pi over 2, what my multiples are going to be. So I would mark off every pi over 2. So you guys told me that cosine actually started at the upper. What do you think would be next in my cycle if I'm starting at upper? Middle, then lower, then middle, then upper. And I don't know why, but to this day, I think of cows when I see this function. Woo, pretend. I don't know. I think of cosine, and then the word cow pops in my head, and I think it has to do with like a bull ring in their nose more than anything. But I know, it's just one of those things that pops in my head every time I see it. But do you guys agree that it almost seems like cosine starts halfway through what the sine looked like? Like if I kind of continued him down, this would be the beginning of sine. Guess what? Cosine and sine, very closely related.
Of course.
Domain. What do you suppose the domain of this function is? All reals. So negative infinity to infinity or all reals. What is the range? Negative 1 to 1. Good. Whoops. Pretend that's a bracket. Amplitude. Distance of 1. Period is 2 pi still.
Why do you have to go to your dad? Go get time with me.
All right. We good? We move on to the next one. All right.
Sounds like a good day to me.
Cosecant. Who is cosecant's buddy? His reciprocal is sine. So what we're actually going to graph is we're going to start by graphing the sine function, but we're going to graph it like he's a ghost. We're going to graph it in a dashed line. Okay? So think about what sine looked like, and if you don't remember, look up 2 problems. And we started with amplitude of 1. If the period was 2 pi, what did I mark for quarter points? What was the first one?
Pi over 2.
Pi over 2, and then his yes factor, so pi, 3 pi over 2, and 2 pi. Okay. Now, mark it, but mark it with a dashed line. Where did sine begin? At 0. And then he went upper, and then he went middle, and he went lower, and then he went middle. This is going to be dashed. Oh my goodness. This is so difficult to draw, and I apologize. Okay, hopefully yours looks a lot better than mine. Okay, the function that we're trying to draw is cosecant. We have not yet drawn cosecant. What I want you to do is draw in vertical asymptotes where your sine function crossed 0. So right here would be a vertical asymptote. Right here would be a vertical asymptote. And right here, whoa, would be a vertical asymptote. Pretend that's vertical. You know what? I'm going to find out that after I recorded this, I probably didn't have the sound on or something goofy like that. Aw, life is going to be bad. Okay. I'm not very happy about this. I don't know.
Hey.
The camera wasn't on?
I think the voice. I think it's on. I think we're good. No, the recording's on. I'm just worried that the volume's not. Oh well. Okay. So now what you're gonna do is every time that the sine function bumps up or bumps down, we're gonna make a mirror image of that bump Okay. So, right here, you've got what looks like a parabola, but it's not. And then right down here, you've got, what looks like a parabola, but it's not. And I see some of you grabbing for your calculator. That's good. How would you type this in your calculator, though?
1 divided by sine.
Okay, go ahead and try typing it in. 1 divided by sine of x, and see what it looks like. You might have to zoom trig one more time, but it might be okay. I'm not sure. Now, your guys' window, if you did zoom trig, goes out to negative 2 pi. That's why you're seeing 4. Mine starts at 0. Yes? Domain is different now, yeah. Domain's very different.
Is it undefined?
Well, there are undefined portions, right? Because of the asymptotes. Can you guys tell me one place where my domain is undefined for this graph? 0. 0 is a problem. Where else is a problem? Pi. Where else is a problem? 2 pi. Where do you think the next problem is? 3 pi. And 4 pi, and 5 pi, and 6 pi. Can you somehow generalize that for me? Every group of pi. And if I went backwards, where do you think the first vertical asymptote is to the left? Negative pi, negative 2 pi. So what we're going to say for domain, you're going to say all x's except...
Oh my gosh.
We'll just say pi k. What that means is k can be any integer, including 0. So that's how 0 works. Integer meaning positive or negative. So if I multiplied pi by a negative 1 or a 50, it doesn't matter. I'm going to end up with a multiple of pi. Okay. I'm not real excited about the range. Does anyone know? And remember, our function is just the blue part. Anyone know how we could say range for this? And let's start with interval notation. How low does this function travel? Negative infinity. And then until what point? Negative 1. You can put a bracket. I'm not going to be too picky about this, whether it's bracket or parenthesis. And then a u, good, whoever said that, thank you. Up to 1. Whoops, that's a 1. And then all the way up till infinity. Very good. Yes. Well, we can't classify it as a number because every number you tell me, I'll tell you something even more negative. Okay, amplitude. What do you think about amplitude? Amplitude, remember, is the distance from the center line.
Infinity.
You're having a hard time coming up with a number because this guy continues forever down and forever up. So is it possible that there is none? There's none. And the period of cosecant is normally 2 pi. And we used the sine function to graph cosecant. All right. Continue. Who do you think we're going to use to help us graph secant? Cosine, yes. So we're going to use the cosine graph. So just like before, you're going to mark off what would have been your cosine's amplitude. Oh, that's really ugly. Sorry. You're going to mark off your quarter points again. Where did cosine start? It started up here at 1. Very good. Now remember, cosine is like the ghost graph. We're not really going to graph him. It's the ghost graph. It's like, remember that show Ghost Rider?
No.
No? Are you guys too young for that?
There was a terrible Nicolas Cage movie called Ghost Rider.
No, this is Ghost Writer. Writer.
What is that? What? That's scary.
It was like, it was around the time of Goosebumps. Did you guys remember Goosebumps?
Yeah.
Okay, when Goosebumps came out the first time, like when you guys were even born, like when I was a kid. That was Ghost Rider time.
Did the Ghost Rider fall in love with?
No.
No?
The Ghost Rider was asexual. It did not have any love components to it. Okay, So, where do you think I'm going to draw in my vertical asymptotes on this graph? Yep. Okay. Woo, that's ugly. Can someone try to think outside the box for a second? Because I haven't told you this yet. Why are there vertical asymptotes, or why is secant undefined at pi over 2? Okay. As Taylor says, if cosine is 0 at pi over 2, and secant is the flip of that, what happens when you flip a 0? Get an undefined value. That's why it's got an asymptote. Okay, remember what we did with cosecant. We're going to draw a little, what look like parabolas at the bumps. So like this is a half parabola right here. If I had the rest of my domain, I would have drawn it over here. Here's an upside down parabola looking thing. Get out of here. And then here's another half bump that I'm going to run out of room for. But do you guys agree it would continue on like this? Okay. If you wanted to type this on the calculator, how would you type it in? 1 divided by cosine. Nice job. Okay. Whew. Fun times.
When I go to Ecuador and eat a guinea pig, I want to pretend to use just remember that you hate someone's pet. It's not anyone's pet. They were discussing that.
All x's except pi.
Well, where are the vertical asymptotes located?
Pi over 2.
Pi over 2, and then I don't think we can say like pi over 2k, because if k was the number 2, what's pi over 2 times 2? Pi. Is there a vertical asymptote at pi?
No.
So what we're going to have to do for domain, and this is kind of strange, I wouldn't expect you guys to know this off the top of your head. It's all x's except pi over 2 plus pi k. What that means is, starting at pi over 2, I would move a group of a full pi in either direction for forever. I don't expect you guys to like come up with that off the top of your head.
Is there something a little more shorthand?
No, I wish there was.
I'm sorry.
Okay, range. Tell me about my range. Good. -a to -1. Union 1 to infinity. Very good. Whoops, that's infinity. Very nice. Okay, amplitude. What do you think about this one? None is the correct answer. And period should be the same. Yep, 2 pi. Okay. It means a union. It means it jumps, because it would not include any of these items in the middle. Are we good to change? Yep. Okay. Okay, tangent. Tangent is an oddball. Go ahead and grab your calculator. Maybe. Where's my calculator? And go ahead and type in tangent. Now, if you have an older calculator, you might see something a little different than what mine is about to show. Ooh, look at that.
That is so cool.
Do you notice that there are more cycles going on in this screen than the previous few? Okay. Well, that means that tangent has a shorter period than sine or cosine. Sine or cosine normally had a period of 2 pi. Does anyone think they know, besides Taylor, what tangent's period is? Pi. What else do you notice about tangent at the origin? He kind of starts at 0, and it almost looks like he must have some sort of asymptotes going on. Okay. Well, let's try this. For tangent, instead of quarter points, you guys are going to mark a center of tangent, which we know is 0. And then I want you to mark out what half of its period is. Well, if its period is pi, what would be half of that?
Pi over 2.
Okay, so right here, mark pi over 2. And even though it's not here, I'm going to kind of cheat. I'm going to back up, and I'm going to mark this as negative pi over 2. I know, I know. And we noticed from our calculator that he kind of did a weird squiggle thing through the origin. Just trust me for a minute and draw in a vertical asymptote, whoops, at pi over 2 and a vertical asymptote at negative pi over 2. Okay, does anyone have their unit circle handy? At pi over 2, that's 90 degrees, by the way. What is the tangent at pi over 2? Sine divided by cosine. 1 divided by 0. It's undefined. Does it surprise you now to know that there's a vertical asymptote at what we're going to call 90 degrees or pi over 2? Okay. Where else is tangent undefined on the unit circle besides pi over 2? Negative pi over 2, yes. 3 pi over 2, yes. So knowing what you just told me, I'm going to call this pi. I'm going to call this 3 pi over 2. I'm going to call this 2 pi. Alicia just told me that there should be another asymptote at 3 pi over 2. Oi, this is a really terrible job. All right, now for the fun. All right. Draw a lot better than I just did, but that's tangent. Okay, that's a little better. If you need a better picture, look at your book or look at your calculator. And then remember, in the middle of the two vertical asymptotes, that's where it's going to cross. So
the person that's listening to this is going to be really thrown off by
y'all are the ones who listen to this.
Yeah, but the other kid that's absent today and doesn't know.
Yeah, that poor child. Oh, poor Jessica. Okay, domain. Domain. There's an asymptote at pi over 2. There's an asymptote at 3 pi over 2. I don't think we can just say everything except for pi over 2k. Same reason as the last question. If I put pi over 2k, what if k was 2? What's pi over 2 times 2? Pi. Is there an asymptote at pi? Negatory. So it's very similar to a problem earlier. We're going to say all x's except pi over 2 plus pi k. So starting at pi over 2, you jump pi to the next vertical asymptote. Talk to me about range. How low, how high does it go? Ah, forever. Negative infinity to infinity. Again, you could put all reals. That would be the same thing. What do you think about amplitude? How high does it go from the center line? It goes forever, so there's none. There's no ending point. How much x value time, how much domain did it take for one period to complete? Pi. Where are the asymptotes? We said pi over 2, and then we said 3 pi over 2. Basically, this is the same question as the first question. Every pi over 2 plus pi. Okay, I think you already answered this for me earlier. Why are these asymptotes? Tangent is sine divided by cosine. And what would have to be 0 to make this statement undefined?
Sine. Cosine.
If the cosine was 0. So why are these asymptotes? Because the cosine value at those points is 0. All right. Cotangent. How could you type cotangent on your calculator? 1 divided by tan. Go ahead and graph it. And it kind of looks different. It's a little opposite. And does someone notice a very slight difference besides the fact that it curves the other direction?
It doesn't go through 0.
It doesn't go through 0 anymore. Think about this, people. If cotangent is cosine divided by sine, where would the vertical asymptotes be located? Where sine is equal to 0. Think about your unit circle. Where is your sine value equal to 0? Where's the first place? At pi would be the first place. So vertical asymptotes, I know there's one at pi. Whoop. Whoop. And I think someone said there's one at 0. I agree. Oh, it really should be a vertical line. So 0, pi, where's the next place? 2 pi. Oh my gosh. It's like not even close to a straight line, Abruzzo. Okay, remember, pi is going to be the period, and you guys can tell from your calculator that he squiggles the opposite way. So his squiggle point in the middle, what is that called right here? Pi over 2. When you go ahead and graph this, he's going to turn around from what the original tangent guy looked like. Oh my gosh. Oh no, that's terrible. Should definitely not be crossing the asymptote. Okay. To prevent my pain of having to draw any more of those, can you guys just graph your own, please? Okay, where do the vertical asymptotes occur? They occurred at 0, at pi, at 2 pi, at 3 pi, at 4 pi, at every pi. So an easy way to say that would be all x's except pi k, meaning every integer multiplied by pi. Range, talk to me about range. Everybody, negative infinity to infinity. Amplitude, none, period. Pi. Where are the asymptotes? You guys told me that it was every pi group. And why are these asymptotes? Alicia told me a little while ago. That's where the sine, which is the denominator, is equal to 0. Very nice. Those are your friends, sine, cosine, tangent, cotangent, cosecant, and secant. I know none of you guys learned this in Algebra 2, right? Even in honors you guys never did, or did you do a little bit in honors? Oh, fun times. Okay, regular Algebra 2 you guys did not do this, so I understand that. We're going to kind of come at it from the approach that no one's ever seen this before, and I know you have, but pretend. It's all right, it'll be like a nice vacation for you. Okay, I'm going to end the recording because this is a really long one.